Okay, let's dive right into this. Welcome to this tactical explainer. Think of this as your exam newsroom, and today we're taking the official Cambridge Physics past papers, specifically looking at syllabus code 9702, though these exact same universal laws apply directly to 0625, 0651, 0652, and 5054, and we are transforming them into a master strategy for maximizing your score. Look, most students fail this paper not because they don't know the physics, but because they completely mismanage the story the question is telling. You've got two types of students. You have Alex, who overloads his answers with raw physics facts but provides absolutely zero analysis. And then you have Sam, who panics, rushes, completely misses the command word requirements, and bleeds marks all over the page. Today, we're breaking down the deadline pressure. We are going to decode the story behind every single question, and I'm going to show you how to deliver the exact headline the examiner is looking for. Here is our agenda for today's briefing. We're looking at the deadline pressure, decoding commands, prioritizing precision over volume, running an interactive data scan, and finally, building the success blueprint. Let's get right to it. Section 1. The deadline pressure. Let's confront the most immediate threat you face the second you open paper 2. The strict, unforgiving exam room clock. You have exactly 1 hour and 15 minutes. That is 75 total minutes to complete the entire paper. Let that sink in for a second. 75 minutes to read incredibly complex scenarios, process intricate diagrams of things like projectile launchers and hydraulic jacks, recall highly specific formulas from memory, perform multi-step calculations, and write out your explanations perfectly. The physical environment of that room is a literal pressure cooker. If you don't have a mathematical approach to your time, I promise you, even perfect physics knowledge will not save you. Now, what's really fascinating here is the math behind the paper. There are exactly 60 marks available. So when you cross-reference that with your 75 minutes, the official Cambridge documentation gives us a ruthless, non-negotiable baseline strategy. You can spend just over 1 minute per mark. That is it. That is your absolute speed limit. 1 mark equals 1 minute. To actually survive this time crunch, you have to stick strictly to the schedule like your grade depends on it, because it does. If a 3-mark calculation involving the kinematics of a golf ball hitting a wall is taking you 6 minutes, you are already operating in a massive deficit. You have to aggressively skip questions that bog you down. Don't be a hero. Secure the easier, quick answer marks first. I'm talking about stating base units or defining electromotive force. Bank those points immediately, and then return to the complex, multi-layered questions only at the very end of the exam.
Moving on to Section 2, Decoding Commands.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's talk about why students bleed marks. The fastest way to lose points is by rushing and completely misinterpreting what the examiner is asking. You must decode command words carefully. The examiner instructions explicitly warn us about this. If a question asks you to describe, you literally just state what is happening visually. But if it asks you to explain, you have to write how or why the phenomenon occurs. You can't just describe what you see. You have to provide evidence from the data and give the core physics explanation behind it. Top students actually use a framework for this called PEAL: point, evidence, explanation, link. You make your point, back it up with evidence from the graph, explain the physics principle, and link it back to the question. Let's look at this in action with an actual exam question from Chapter 7 on the Young modulus of a copper wire. Question 2C, Part 1 asks, explain what is meant by the limit of proportionality for a wire. It is worth exactly 1 mark. Remember our rusher, Sam? Sam writes, it's when the wire stretches. That's not an explanation, and honestly, it's barely a description. 0 marks. Then you have Alex, the overloader. Alex writes a massive, sprawling paragraph detailing Hooke's law, plastic deformation, and intermolecular forces, wasting 4 precious minutes for a single point. Applying our command word rules to explain for 1 mark, you need the why concisely. The perfect targeted headline answer is simply the point up to which the extension is directly proportional to the applied load. Boom, 1 sentence, 1 point, 1 mark. Section 3. Precision over volume. There is a massive, widespread misconception that writing more equals a better grade. The official examiner instructions literally say the exact opposite. The best answers are short and relevant. That is a direct quote from the Cambridge Strategy Guide. Targeting your answer precisely means you can secure a huge amount of marks with a very small amount of writing. You do not get extra credit for dumping everything you know about the alpha particle scattering experiment if the question only asks for the conclusions drawn about the size of the nucleus.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGC and turn on all notifications so you never miss our weekly exam strategy sessions. All right, as a general rule, there will be twice as many answer lines as marks. So if you're looking at a 1-mark question, you'll have about 2 lines of blank space. If you find yourself writing more than 6 lines for a 3-mark question, your answer is completely unfocused. You are wasting the precious minutes that you desperately need for the complex calculation questions waiting for you at the back of the paper. Keep it tight, keep it relevant, deliver the headline.
Now, for math-heavy questions, precision is all about showing your steps. Step 1. Always write out the formula first. Step 2. Show the examiner what you are doing by actually writing down your workings. Step 3. Calculate the final answer. Why is this so absolutely crucial? Because the examiner instructions explicitly state that there are often several marks awarded just for the calculation process itself. Even if you make a silly arithmetic error early on, which happens to the best of us under pressure, the examiner can still award you marks for the rest of the process as long as they can understand what you are trying to do. If you skip the workings and just write down a wrong final number, you get a 0. Show your work and bank those partial marks.
Section 4. The interactive data scan.
Okay, let's put all of this theory into practice under pressure. We are going to run a visual data scan challenge directly from the exam paper. Look at this complex data source from Chapter 2. It's a velocity time graph. The scenario is this. A builder throws a brick straight up to a second builder on a scaffold, who catches it. The graph shows the velocity of the brick from the moment it leaves the first builder's hand to when it's caught. The velocity starts at 9.8 meters per second and drops linearly over time, crossing the x-axis right around 1.0 seconds. You've got 60 seconds on the exam clock to extract the core trend here. Scan it.
All right, time's up. Here is your challenge. The question asks, the gradient of the velocity time graph is negative. Explain what this shows, for 1 mark. A very common flawed answer goes something like, the line is going down because the velocity is dropping. 0 marks. Why? Because that just describes the visual of the graph. Remember, the command word is explain, and since it's 1 mark, you have a maximum of 2 lines of text to get this right. Let's do a speed writing challenge. You need 1 perfect sentence. The perfect physics headline here is, it shows the brick is decelerating due to the constant downward acceleration of free fall. That sentence provides the fundamental why. That is exactly how you secure the mark. Let's run a second scan on an even more complex diagram. This one is from Chapter 4, demonstrating the principle of a hydraulic jack. You have a vertical force of 50 newtons applied at one end of a lever pivoted at point A. The plunger is pushed down, creating pressure on the oil, which is transmitted through to the slave cylinder to lift a heavy load. We've got a plunger area of 4.0 times 10 to the negative 3 square meters and a slave cylinder area of 1.6 times 10 to the negative 2 square meters. Take it all in. So, the crucial skill here is applying your foundational knowledge to a completely new situation. The question asks, suggest 2 design changes to the jack so that a larger load could be lifted, for 2 marks. The command word here is suggest. This is tricky because it means there isn't just one static right answer you could have memorized from a textbook. You have to actively apply physics principles. Think about your formulas. Pressure equals force divided by area. Moments equal force times perpendicular distance. You need 2 brief, distinct bullet points for 2 marks. Change 1. Increase the distance from the pivot A to where the 50 Newton force is applied, which directly increases the input moment. Change 2. Increase the cross-sectional area of the slave cylinder, which increases the output force for that exact same fluid pressure. 2 clear, distinct points. 2 marks secured. We move on.
Section 5. The Success Blueprint. Let's pull everything together.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. This right here is your exam execution strategy matrix. You must follow this timeline strictly. At minute 0, you start that 1 minute per mark pace immediately. By minute 15, you should be scanning and identifying unexpected, difficult scenarios, maybe a weird projectile motion question or a super complex Kirchhoff's law circuit, and you aggressively skip them. Do not let them ruin your momentum or your confidence. By minute 45, you must have secured all the easy marks from basic recall questions and written down all your calculation workings for partial credit. By minute 60, you have 15 minutes left on the clock. Now, and only now, you use this buffer time to loop back and fight for those difficult questions you skipped earlier. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. If you remember nothing else from this explainer, you need to memorize these golden rules to stop bleeding marks. 1 mark equals 1 minute. 1 mark equals roughly 2 lines of writing. The word explain explicitly demands the how or the why, so never just describe the visual data. Always write your formulas down first before plugging in numbers, and finally show absolutely all of your calculation workings to guarantee partial marks, even if your arithmetic fails you under pressure. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Those 60 marks are sitting right there on the table, waiting for a prepared, strategic mind to claim them. You now know exactly how the examiner thinks, how the clock works, and how to structure your answers for maximum impact. So the final question is, will you let the ticking clock control your performance, or will you command the paper? The choice is entirely yours. See you next time.